Okay, here we go. All right, so we've been factoring now, and we saw one technique of factoring, if you remember, right? One technique that we saw had to do with the greatest common monomial factor, basically determining what that is. And not only that, but also factoring it out. That is one method of factoring. Sometimes that might be the only kind of factoring you can do. It depends on what you're given. Here, what we're going to look at now is factoring trinomials. I know we started this last time, but I want to start from here. So basically, the idea is, suppose you have this kind of trinomial. You have x squared plus b times x plus c. Notice that since the leading coefficient's 1, okay, that tells you that the greatest common factor among the coefficients and the constant term has to be 1. In other words, if you back to the GCF with b times x to the m, that b would have to be 1. And since there's a non-zero constant term, your m would have to be 0. So in other words, there's the GCF from this kind of polynomial is 1. But we can still factor it. And that's what I was trying to show you last time. Basically, you want two numbers, little b and little d, whose product is c and whose sum is b. And that's what I'm trying to show you here. You want to fill in these blanks, so to say. The product, okay? The product has to be b. Excuse me, the product has to be c. And the sum of those two numbers is b. And what do you do with those two numbers? Well, you do this. Basically, you get a factorization. Okay, so now we can do some examples. I think I might have done this one last time, but again, I feel better going through it again. So let's suppose we want to factor this, x squared plus 7x plus 10. Well, we have that kind of trinomial, right? 3 terms, degree 2. Leading coefficient is 1. Later on, we'll see how to handle this if the leading coefficient is not 1. But for now, since it's 1, we could dive right into this method. Okay, so we want two numbers, right, whose product is 10. The sum, though, has to be 7. Okay, so the product has to be 10. The sum has to be 7. Now, what I have here, of course, is not right, but I'm just showing you that if you were to try 10 and 1, you would see that, well, that doesn't work, right? 10 times 1 is 10, but the sum is not equal to 7. Okay, what numbers will work? Well, how about 5 and 2? The product is 10, right? The sum is 7. These numbers are going to work. So because of that, okay, because of that, 5 and 2 are the numbers we choose. So that tells us we can factor this as follows. Again, 5 and 2, let me go back, are the numbers whose product is 10 and whose sum is 7. Product is 10, sum is 7. So we get this. And what's nice about factoring is it's not that bad to check. It's just multiplication. And that's what I'm doing here. And you can see that when you actually multiply, or FOIL in this case, you end up getting what you started with. And that's what we wanted. So this is correct. Okay, that's good. Okay, that's one example. Well, let's look at another one. Let's say now we have x squared minus 9x plus 20. Okay, so again, same idea. We have a trinomial, right? In this case, b is a negative number, which is what subtraction tells us, but that's okay. And we have c, degree 2, leading coefficients 1, so we can use the method that we just used. So we want two numbers, okay, whose product is 20 and the sum is negative 9. So we want two numbers whose product is 20 and the sum is -9. Well, again, 10 and 2 are not going to work, right? This product is 20. Excuse me, the product is 20. That should be a 20 there. Let me fix that. So this should be 20. Okay. And the sum, of course, is not -9, right? So these two numbers, 10 and 2, don't work. Now, what about 5 and 4? Well, 5 times 4 is 20. Okay, so that's good. But the sum is not -9. 5 and 4 is 9. So because of that, 5 and 4 don't work. But you can see how we can almost make it work. Basically, you should be thinking, well, what if we negate 5 and 4? In other words, -5 and -4 will work. Right? The product is still 20 by our sap and sun rules. The sum is now -9. So -5 and -4 are the numbers we can use. Okay, so let's do that. And so we get this product here, as you can see, is going to be x minus 5 times x minus 4. Let me just go back. Again, we have minus here. Minus. So that tells us this is going to be x minus 4 times x minus 5 times x minus 4. And again, it's good to check. Namely, we look at this product, and it should give, and basically we're checking, does this equation really hold? Well, we're carrying out the multiplication. Doing so, we get what we started with. Good. So we're in good shape. It's always good to check. I mean, with factoring, it's actually easy to check. I mean, factoring itself is pretty complicated, but it's actually not that bad to check, though. Okay. Now, here's another one. This was originally a backup one, but it's not really backup, I guess, anymore because have plenty of time to do it. All right, so now this one here, what we're going to do is we're going to factor this. Let me just check something. Just was concerned. I thought people had questions, so I was just a little concerned. All right. So now what we want to do is we want to factor this, 2x squared and so on, plus 24x plus 40. Oh, wrong one. Now, at first, it looks like we can't use this technique, right? Even though we only have 3 terms, the polynomial is of degree 2, the leading coefficient is 2, not 1. So at first, it looks like we can't use this technique. But let's see if we could let's find the GCF and see if we can factor it out. I mean, right away, you should be able to see what I have written here, that m has to be 0. In other words, the GCF is not going to have a variable because we have a non-zero constant term. Okay, and again, we're using that convention, that imprecise one, that x to the 0 is 1. But let's look at the coefficients and the constant term. I mean, if we know that 2 itself is a factor of 24 and 40. That forces 2 to be our b. Basically, the greatest common factor among 2, 24, and 40 has to be 2. So we get b is 2. So in this case, our GCF is just 2. I mean, you could list the factors for 24 and 40 if you wanted to, but we don't have to, which is nice. Saves a little time. Okay. So that's good. Now let's get that 2 out of there. In other words, we're factoring out the GCF, right? Remember what you do, you put it in front, and then you have to divide to get what's left over. And when you divide, what do? You divide into each term. When you're dividing into a sum, you divide into each term, like so. And so what do we get? We get 2 times. Here, let me get the pen again. Okay. So we get 2 times. As you can see, these 2's cancel. That's good. That's why we get 1 over here. 24 over 2 is 12. 40 over 2 is 20. So what we're left with this. And notice what's in parentheses here, x squared plus 12x plus 20. This we can factor because this is what we have now. This is degree 2. Its leading coefficient's 1, and there's 3 terms. So now we can factor this one. So now we're looking for 2 numbers. I mean, you can see what they are already. We're looking for 2 numbers whose product is 20 and the sum is 12. Well, again, we have 2 numbers, 10 and 2, right? The product is 20, the sum is 12. So 10 and 2 is what we're going to use. Okay, let me just hold on. Let me just pause this.